The notes, like I said, they're in the folder. They look like this, okay? And yesterday you might have heard me refer to our maxes and mins as turning points, right? Essentially, they are the same thing. It's a place on our graph, it's a point on our graph where we transition in our curves, right? Because we're dealing with polynomials. We go from up to down or down to up. But in a little bit more of a mathematical sense, between these points, our figures are either increasing or decreasing. All right, and that's where the center of our focus is going to be for today. Where's my graph increasing from? Where is it decreasing from? The point in between those two ideas is where I have what's called my turning point, right? And our turning point is going to be a max or a min. All right. So what we're going to be able to do just by looking at any graph and what you're going to be able to do on your assignment tonight and on the quiz on Friday is to be able to just locate those turning points, understand intervals of increasing, decreasing, understand, domain and range, which we're going to add on top of this as well, and kind of just continue to solidify the characteristics of a polynomial graph, okay? So if I'm looking at this figure off to the right, okay, we'll use this as our first example here. Notice that from left to right, we're always going to look at our graph from left to right. Where am I starting to decrease? Where am I starting to increase? So I'm following this trend where my Y values are getting smaller, right? All the way until I get to this point here. So when my Y values are getting smaller, this is where my graph is decreasing. Okay. So when Y values get smaller, your graph starts to decrease until it gets to this point down here. And then just like we saw yesterday with our tables, my Y values are going to start to increase again. The point at which you start to increase again after decreasing is called your turning point. Now, using a word like max or min, what would you call this point? A min, right? That's a minimum value. So that would be my relative minimum. I go from decreasing to increasing, just trying to connect the ideas from yesterday. So when it asks for what are the turning points, you would give, on your homework tonight or on the test or quiz, you could give the X value, you could give the entire coordinate. So you're just going to look at this point here and ask yourself, well, where is that in my plane? That's at the coordinate -2, -3. If it just asked you for the X coordinate to estimate the X coordinate of that turning point, you would just say -2. Okay. That's one turning point. That's one change from decreasing to increasing. Then I go to increase and I continue to increase till I get to this point here. And then I start to decrease again. What's the coordinate of that turning point? 1, 3. What's my coordinate of the last turning point? 3, 1. Right? Essentially, all you're doing when it's asking for what the turning point is, you're looking at the intervals of increasing and decreasing. You're seeing when it makes that transition or that shift, and then you're just going to put that point or that X coordinate, depending on what it asks you to do, down for your answer. Okay? Any questions so far about what a turning point is? The next thing we're going to discuss in our examples is to look at where our graph is increasing and decreasing. So the first one we're going to take a look at is increasing. We're going to be talking about intervals. So between certain values, where am I increasing? Where am I decreasing? All right. When we name these, similar to how we named our zeros, similar to how we named our maxes and mins, we're using our X values. Okay. So if we look across this graph from left to right, when am I decreasing? When am I increasing? And at what values does that stop and start? Okay. So if you want to make a note of that, make sure that you write down you're looking at X values for increasing and decreasing. So for example, if I'm taking a look over here, we'll start with just increasing. I'm increasing from this point here to this point here, right? Between two turning points. So between which two x values am I increasing? -2 to 1. At -2 is when I start. At +1 is where my second turning point, or my second turning point is. That's when I start to decrease again. So I'm only increasing between those values. Where else do I start to increase? What's the point where I increase again? So from 3. And these graphs, something that we want to make sure we understand is that these graphs, they continue on for forever. So although we only see them in this like 10 by 10 box here, they go on and they continue to increase or decrease and move in each direction for forever, right? So when we're talking about increasing and decreasing, we want to include negative infinity and positive infinity somewhere in our answer, right? And we'll explain why that is in a second. But technically from 3 all the way on, if I continue on in this direction for forever, my graph's going to continue to increase. So it's from 3 to infinity. Any questions about the intervals for increasing? Remember that we're only taking a look at the x values. My interval for decreasing, it starts decreasing all the way over here. What do you think that value is going to be if I look at my x's in this direction continuing on for forever? Where would that start? So it's going to be an infinity, but it's going to be negative infinity. Okay. So all the way over here in the positive x direction is positive infinity. All the way here is negative infinity. All the way down in this direction is negative infinity. All the way up in this direction is positive infinity. And then I start to decrease in that direction until I get to what point? -2. So from negative infinity to -2, excuse me, I'm decreasing. Right? Remember, we're just looking at x values. Don't confuse that with decreasing from negative infinity to -3. It's to whatever that x value is, where my turning point is. Maybe somebody from home help me out with this one. Where's my second interval of decreasing from? Between what two x values? Where else on this graph am I decreasing? If I'm looking across here.
1 to 3.
From 1 to 3, good. So from 1 to 3, that's the other interval where my graph is decreasing. Okay. The other two things that we want to discuss relating to graphs of polynomials, and you're going to see this throughout math in a lot of different areas, is what's called domain and range. And some of you may have heard these terms thrown around before. Domain and range. Domain essentially is if I look at my graph from left to right, so from all the way over here to all the way over here, okay, do I have all of my x values accounted for? So an x and a y, an x and a y. If I look across, all of my x's have some y value attached to it. So my domain is going to be, and for this case, when we're talking about our polynomials, anything that we're going to see right now, our domain is from negative infinity to positive infinity. It's always going to be the case. All right. Domain is looking at our graph from left to right, seeing if we have all of those x values accounted for, and we're good. Range, on the other hand, so domain's left to right. Range, on the other hand, depends on your bottom to top. So from the bottom of this graph all the way to the top of the graph, where are my y values? What are they being accounted for? Okay. So sometimes, especially with polynomials, your range may fluctuate. It's going to change based off of the function that you're given the graph. So my range, notice that for this particular example, I don't start any of my y points, right? I don't have a y point until I get to -3, right? There's nothing going on below it until I get to this point here. So your range is where your graph starts on the bottom. In the y values, remember, domain, we're talking about x's, range, we're talking about y's. So from -3 all the way up to wherever your graph ends in the y values. Well, if these continue on forever, what would this point be over here? It goes to infinity in your y values. So from -3 to infinity. Okay. And again, the range is going to depend on the graph that we're given, the function that you're given, and some of those values. So it might change, whereas the domain for right now is from -infinity to positive. Any questions about some of the terms that we've discussed so far? All right. We're going to take a look at 3 different examples of just being given a graph and determining the turning points, increasing, decreasing, and then we're also going to throw in domain range. Okay. So if I'm looking at this graph in example 1, looks like I'm decreasing until I get to this point here, and then I start to increase. So that point is my turning point. What is the coordinate of that turning point? So -2, -2, right? Both negative. And then I'm increasing until I get to this point, and then I start to decrease again. Maybe somebody from home, help me out with this one. What is the coordinate of that second turning point?
One, 3 or 1, 2. It's hard to see.
It's 1, 3. Yeah, my apologies. It's a little small. So 1, 3 is my second turning point. Good. Now we're going to list our increasing and decreasing intervals. Now, keep in mind, right? I'm increasing and decreasing between those turning points. So you're going to use these values to help you with your intervals, right? And you're going to see some overlap in your intervals when you're listing them. So let's start with increasing. Between what 2 x values am I increasing? Because I only have one interval of increasing values here. From -2 to 1. Good. Right? From this point here, -2 to +1 in my x values. Remember, we're talking about x values. That's where I am increasing. Where am I decreasing from? -infinity to -2. Good. And then, all right, so careful, right? So -infinity to -2, but then you went to the y value. Remember, we're talking about x's with our intervals. So what's the x value? 1 to infinity. Right? So just be careful. Always dealing with x's when talking about your increasing and decreasing intervals. Okay? Any questions so far? What is always your domain of these polynomial functions? What did we say it was? Good. -infinity to infinity. Your range right? It's whatever the lowest y value is to your highest y value. Start from the bottom to the top. Now, one thing, like I said, for all of these graphs, they do continue on in both directions for forever, unless it's very distinct that you have an end. So for this one, although, like I said, we're in this 10 by 10 space, this is going to continue on in this direction forever and this direction. So my range is actually from negative infinity to positive infinity. Okay. Any questions about that first example? All right. Let's take a look at example 3. Maybe somebody from home help me out with the turning point for example 3. When do I start to go from, in this case, increasing to decreasing? What's my turning point?
-2, +2.
Good. -2, +2. And then on your homework for tonight, it might just ask you for the x value. It says like estimate the turning point or the x value for that turning point. You would just say -2. All right. -2, +2 is my turning point. The interval on which I am increasing. Somebody help me out with that. Good. From negative infinity to -2. Right? My x value is all the way over here is where I start to increase until I get to this point here. And then I start to decrease from where? What's my interval of decreasing? Good. From -2 to infinity. Right? From this x value here on for the rest of the graph, I am decreasing. Any questions about that so far? What's my domain going to be? Good. Negative infinity to infinity. And now my range. So something that's a little bit different now, right? I start from the bottom, I work my way up. So like I said, this graph continues on in both directions for forever. It's going to start at negative infinity. But then I only increase until I get to this y value here, right? That's the highest y value that I have. There's no points above that. Range, remember, is talking about y values, domains x values. So I go from negative infinity all the way up until I get to +2. Okay. And at +2, that, excuse me, is where I end my whole range of y values. So that's where I'm going to write my interval from. All right. Any questions about example 3? All right. Let's see if you can do example 4 on your own and then tell me everything that I need to know about this. What are my turning points? I have a couple turning points here. Okay, so -3, 1, -1, 4, and then 2, -3. Good. So -3, 1, -1, 4, and then 2, -3. Those are my 3 turning points, right? And in between those turning points, I am increasing and decreasing. Somebody from home, tell me the increasing intervals. There's two increasing intervals that I see here. What are those intervals going to be between what x values?
-3 to -1.
So from -3 to -1, good. Where else?
And then +2 to positive infinity.
Awesome. From +2 to positive infinity. Good. Somebody different, tell me the decreasing intervals. Good. Negative infinity to -3, -1 to +2, right? And that's it, right? So one thing that we want to notice, especially it might be a little bit easier to kind of see when we have multiple intervals, excuse me. But your turning points and your increasing and decreasing intervals have some overlap, right? Negative infinity to -3. Then I go -3 to -1. So my next interval of decreasing should start with -1, -1 to 2. My next interval of increasing should start with 2, 2 to infinity. So you see that there's kind of a sequence or an overlap that you should see between your increasing and decreasing and your turning points. And that should make sense because that's the nature of what a turning point is. What's my domain here? Right, negative infinity to infinity. And my range. Good, nice. So -3 to infinity, because my graph does not start anywhere below -3, right? It starts when I get to that value. So from -3 all the way up to positive infinity is where I have y values. That's going to be my range. Okay. Any questions for me about anything that we covered today with turning points, increasing, decreasing, domain, or range? Okay.